All right, welcome. Now we're going to talk about relative maxima and relative minima. These are like the local minimum. They're also called local minima or local maxima. So you might have a minimum value on the graph, or there might be a maximum value on the graph somewhere, and we're usually interested in where they are located and what their value is. Okay, so here are the definitions of what a local maximum is and what a local minimum is. Okay, maxima, just so you know, maxima and minima are just the plural of maximum and minimum, right? From the Latin. Okay. Okay, so here, definition one for a relative maxima or local. So let me write local. So sometimes we use the word local. So local. Okay. Now, f of a. So f of a is a relative maximum of the function f if there exists an open interval I containing a such that f of a is greater than or equal to f of x for all x in the interval I. Okay, so I use symbolism here just to keep down on the writing. So this just means there exists. The upside down a is for every or for all. Okay, and this means an element of. Right? So this is x is an element of the interval a, so x is in a. Okay? This is just shorthand for such that. So just things that I write just to keep things simple, so it's not a lot of writing. So this is the definition of having a relative maximum. Okay? Now, what about a relative minimum? Very similar. So f of x is a relative minimum if excuse me, let me say that again. F of x is a relative minimum of f if there exists an open interval I containing a such that f of a is less than or equal to f of x for all x on the interval I. Okay, so those are the technical definitions of when we have a relative maximum, relative minimum. And then we're going to look at an example.